Hi, and today we're going to be solving binomial expansion equations using Pascal's triangle. Now, the other way you can do this is you can FOIL it out, but that would take up all this space right here. But there's another quick shortcut you can use, and that is using Pascal's triangle. So the first thing I like to do is label the rows. You have row 0. Don't ever forget row 0, because it will throw off the entire triangle if you don't put row 0 in there. Because then you have row 1, row 2, row 3, row 4, and then row 5. Take a little extra space. Let me just put a little line to separate where I put the triangle. Alright, in row 0, you always have 1. And then after that, it's 1, 1, 1, 2, 1. Now the 2 arises out of 1 plus 1, which is 2. It's always the one beneath the 2 of these, like in a triangle, like here. Then you have 1, 3, 3, 1. Then you have 1, 4, 6, 4, 1. Then 1, 5, 10, 10, 5, 1. Because you just have, for example, here 4 plus 1 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then 1. Alright, so now after this, all you have to do is match up, these will be the coefficients of the main equation. All you have to do is match that up with the row x to the 5th is equal to row 5. So we'll just come back to this later. These will be the coefficients of the equation. Now the next thing you have to do is label out all of the, here, I'll just put it here real quick, x to the 5th, like you start with x to the 5th, then you go x to the 4th, make sure you leave space in between, x to the 3rd, save you a lot of, calculator, yeah, put the y there by accident, x, and then you start counting backwards from y to the 5th, y to the 4th, y to the 3rd, y to the 2nd, then y. Alright, see, you just count x to the 5th all the way down to x, and then y backwards to just y. Now this is where you plug in the coefficients. You take 1 would just be 1, so that you can just leave that x to the 5th. But then you have the 5 here, a 10 on the next one, 10, 5, and then 1. So that would cancel out, or not really cancel out, but then just add little plus signs, and then this is actually your answer right here. See how fast that was? You don't even have to FOIL out anything. It's just do the triangle and then just count x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, then x, and then just count backwards y to the 5th, and just add that on. They get more complicated as we go on, and in the next problem I'll show you a slightly more complicated problem, but they never get too complicated because you're limited to class time for a test. So I'll just do another one. Alright, now this next problem is slightly more complicated. It'll mix things up a bit. It's 2x plus y to the 5th. Now you'll see what a slight 2 will do to change the entire problem. Now we follow the same rules as last time. You just count out x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, then x, and then y to the 5th, y to the 4th, y to the 3rd, y squared, and then y. But this time, since it's 2x, all you do is add a 2 in front of the x's here. 2, 2, 2. Alright, wherever this x, just add 2. Alright, so we have this so far. Now the next thing you have to do is multiply the 2 by the exponents of the x. Now this is what I mean by it could get pretty tricky, and why you're limited to a certain amount of time. So 2 to the 5th is, let's see, 32x to the fifth plus 16x fourth y plus, and that's 8x x to the third y squared plus 4x squared y to the third plus just then 2xy to the fourth y to the fifth. Alright, so since this is still on the fifth row of Pascal's triangle, we still use these same things right here. Now, all you have to do actually is just multiply the coefficients in this equation by the coefficients in the Pascal's triangles, in the row in the Pascal's triangle. So it actually turns out to be, hold on 1 second. So 1 times 32 is 32. So then we're left with 32x to the fifth. All right, plus. Now 5 times 16 is 80. So we have 80x to the fourth y. All right. So then we have 10 times 8, which is also 80, plus 80x to the third y squared, plus, now we have the 10 here, times the 4, which is 40, so then you have 40x squared y to the third, plus, now 2 times 5 is 10, so left with 10xy to the fourth, and then the last one is just y to the fifth. Y to the fifth. And this is the answer to 2x plus y to the fifth. See how it's just an extra step in here. It'll take you slightly longer. So just to recap, all you have to do is just do out the normal x to the fifth all the way to just x and then y to the fifth backwards. Then you just fill in the 2 where the in front of the x is. Then you just multiply the 2 by the exponent here. So you get 32, and then like the same here and all the way across, and then you just multiply by the coefficients, whatever you just multiplied here. So by the exponent here. So just on one example right here, it's just 2 to the fifth, which is 32, and then 32 times 1 was 32, and then so on and so on. 2 to the fourth was 16, and then 16 times 5 was 80. So, and then you just go through like I showed you. You can go back and check over the video if you need a recap. So that's it for binomial expansions in Pascal's triangle. If you would like more videos, I can do more examples in the future. So, well, that's it for this, and leave any comments in the section below if there is anything you'd like, or if there's any problems. Alright, thanks.